So hi, so here is my matrix number. So after the 0, the integer is 46, so my resistance is 46 kilo ohm, and then I have to find the value of capacity that I use using the formula of impedance. So yeah, the value I got is 3.46 nano. So now we'll be constructing the RC circuit. So first and first, I will need the voltage generator, make it bigger, and then I will need a resistor for sure, and then a capacitor that will connect. Oops. We'll connect the components with wire. Okay, and then I put the ground here. And then enter here voltage pin. So I just adjust the component value from 46k. Okay, this one 3.46 nano. Okay, one, because we're using sinusoidal, so we need to change into sine wave 1000. 1000. Alright, all set. Now I can run the oscilloscope. Oops. Okay, here the mode I put as normal, the source from CF1. Oh no. I need to adjust first to make it obvious. Alright, it should be fine. Then I have to make this smaller. Okay, and then I'll adjust PF2. Yes, okay. Stop. And for press 2, I use the B cursor to find the phase shift. Alright, nice. Okay. For A cursor to find the okay, so yeah. Now I'll be exporting the data into Excel. Okay. Export. The curve RC. Yep. Test. Okay, open file. Then I will copy put into Excel. Alright, and with all the data, I will make a graph. Oops. Now we have to redo. Set data. Okay, so we got the graph already. I name it as RC circuit. $1K Hertz. Alright, yeah, now we have all the data and also the output graph. So the blue one indicate the VF1, the orange one indicate the VF2. Okay, so now the last step is to calculate the phase angle. So the formula is 360 divided by period. Period we can get 1 over frequency. So it is 1 milli. So 1 E negative 3 times phase shift. So phase shift we can get from the data here, which is this one, negative 122.74 micro, negative 122.74 micro, E negative 6. So yeah, so that's the phase angle. I think that's all from me. Thank you.